Okay, so now we're going to move on to Le Chatelier's principle. Okay, all this principle says is if you add reactants or products to a reaction, it's going to affect it. All right, and so what this principle tells us is when equilibrium is stressed, then it will shift in a way that relieves the stress and reestablishes equilibrium. So if we have a reaction going along, and we add some reactants to it, okay, then it's going to shift and it's going to go faster to account for the reactants that have been added. Okay, and so, but the same thing with it being equilibrium reactions, it's going both ways. All right, so if you add reactants, then it's going to shift the equation further towards the product because you're adding a concentration. You're adding the concentration of reactants, so it's going to use them up more. Okay, and if you add products, or if you take reactants away, but if you add products, then the same thing, it's going to push the reaction this way because then it's going to have a higher concentration of products and it's going to shift the reaction. So what Le Chatelier's principle tells us is when you add, like if you add reactants, it's going to shift the reaction towards products. If you add products, it's going to shift it towards reactants. So in general, it shifts it away from where you added the extra amount. Okay, and so that is a pink box on page 496, and it tells us equilibrium will shift away from the side that experiences an increase in concentration. It will shift toward the side that experiences a decrease in concentration. So typically, obviously, when you're doing an equation, a lot of times we are just adding more of something. And so if we add more reactants, then it's going to shift the reaction towards the products. Okay. So the rest of the chapter is gonna cover Le Chatelier's principle in different ways, but I want to, and this is where when you don't include the solids or liquids in accounting for the change in concentration, where this comes to life, and you have to remember that concept. Okay, so if we look at example 16.5, it gives us the equation. This is a long one. 4Cu plus. Okay, and this is aqueous. Remember, aqueous is not liquid. Aqueous is going to be accounted for in an equilibrium calculation. Solid sulfur plus 3H2O, and that's liquid. Okay, those are our two. Okay, and that's 4Cu solid plus H2SO3 aqueous plus 4H plus aqueous. All right, so the question is, what will happen to the concentration of H plus aqueous, all right, if more Cu plus is added? Okay, Cu plus is aqueous, H is aqueous, so they both do, changes in concentration of those do affect the rate of reaction. All right, so it's saying if we add a reactant, so when we add a reactant, if you remember Le Chatelier's principle, if we're adding a reactant, it's going to shift towards the H2 or the H plus. Okay, so it says what will happen to the concentration of H plus if more Cu is added. Okay, well, it shifted it this way, so that means more H plus. It's going to increase. Okay, so H plus will increase if we add Cu plus. The next part, B, says what will happen to the concentration of H plus if H2SO3 is removed. Well, we're looking at a product again. If we remove a product, okay, we lowered the concentration of this, we removed it, that means these increase. So that means it's also going to increase the amount of H plus, because decreasing a product is like increasing a reactant. Okay, so if you decrease a product, it has the same effect as if you increase a reactant. So it's also going to increase the H plus. All right, and the last question, what will happen to the concentration of H plus if S is added, if solid sulfur? Okay? Now, look at this. Look at the phase. We can add all the sulfur in the world and it's not going to do anything because it doesn't have anything to do with the rate of the reaction. Okay, so adding solid sulfur, removing solid sulfur is not going to affect the amount of is not going to affect the concentration of H+. Not that it won't affect the amount, but it won't affect the concentration of the H+. All right? So again, you have to understand this relationship because there will be questions on the test that are similar to this, that are in general. If I add this, if I add some product or reactant, what's it going to do to the concentration of a product or whatever? Just know the relationship. So if anything is done with the sulfur, if anything's done with the water, or if anything's done with the copper solid, doing anything to any of these three are not going to affect the concentrations of any of these other ones because they are not accounted for in the equilibrium constant because their concentration does not change. All right? So I'm going to end this video.